Key architecture and design principles. Let's see the key principles to be considered while designing an architecture. Build to change instead of building to last. Consider how the application may need to change over time to address new requirements and challenges, and build in the flexibility to support this. Reduce risk and model to analyze. Use design tools, visualizations, modeling systems such as Algo to capture requirements and design decisions. The impacts can also be analyzed. Do not formalize the model to the extent that it suppresses the capability to iterate and adapt the design easily. Use models and visualizations as a communication and collaboration tool. Efficient communication of the design, the decisions, and ongoing changes to the design is critical to good architecture. Use models, views, and other visualizations of the architecture to communicate and share the design efficiently with all the stakeholders. This enables rapid communication of changes to the design. Identify and understand key engineering decisions and areas where mistakes are most often made. Invest in getting key decisions right the first time to make the design more flexible and less likely to be broken by changes. Use an incremental and iterative approach. Start with baseline architecture and then evolve candidate architectures by iterative testing to improve the architecture. Iteratively add details to the design over multiple passes to get the big or right picture and then focus on the details. Key design principles. Following are the design principles to be considered for minimizing cost and maintenance requirements, and maximizing the extendability, the usability of architecture minus. Separation of concerns. Divide the components of the system into specific features so that there is no overlapping among the components' functionality. This will provide high cohesion and low coupling. This approach avoids the interdependency among components of system, which helps in maintaining the system easy. Single responsibility principle. Each and every module of a system should have one specific responsibility, which helps the user to clearly understand the system. It should also help with integration of the component with other components. Principle of least knowledge. Any component or object should not have the knowledge about internal details of other components. This approach avoids interdependency and helps maintainability. Minimize large design upfront. Minimize large design upfront if the requirements of an application are unclear. If there is a possibility of modifying requirements, then avoid making a large design for whole system. Do not repeat the functionality. Do not repeat functionality specifies that the functionality of components should not be repeated, and hence a piece of code should be implemented in one component only. Duplication of functionality within an application can make it difficult to implement changes, decrease clarity, and introduce potential inconsistencies. Prefer composition over inheritance while reusing the functionality. Inheritance creates dependency between children and parent classes, and hence it blocks the free use of the child classes. In contrast, the composition provides a great level of freedom and reduces the inheritance hierarchies. Identify components and group them in logical layers. Identity components and the area of concern are needed in the system to satisfy the requirements. Then group these related components in a logical layer, which will help the user to understand the structure of the system at a high level. Avoid mixing components of different type of concerns in same layer. Define the communication protocol between layers. Understand how components will communicate with each other, which requires a complete knowledge of deployment scenarios and the production environment. Define data format for a layer. Various components will interact with each other through data format. Do not mix the data formats so that applications are easy to implement, extend, and maintain. Try to keep the data format the same for a layer, so that various components need not code/decode the data while communicating with each other. It reduces processing overhead. System service components should be abstract. Code related to security, communications, or system services like logging, profiling, and configuration should be abstracted into separate components. Do not mix this code with business logic, as it is easy to extend, design, and maintain it. Design exceptions and exception handling mechanism. Defining exceptions in advance helps the components to manage errors or unwanted situations in an elegant manner. The exception management will be the same throughout the system. Naming conventions. Naming conventions should be defined in advance. They provide a consistent model that helps the users to understand the system easily. It is easier for team members to validate code written by others, and hence will increase the maintainability. That's all for today in Key Principles of Architecture and Design Principles. Thank you for watching.